We've all seen the classic Back to the Future movies, but have you ever wondered how exactly the flux capacitor works, or how Marty's hoverboard manages to fly over thin air? Well, scientists have actually been researching time travel and levitation technology for years, and we may actually be closer to this futuristic technology than you think. If you're not already familiar with the series, basically a genius scientist named Doc Brown invents a time machine that allows him and his teenage friend Marty McFly to go back in time. But when Marty runs into the teenage version of his mother, he accidentally causes a chain of events that causes him never to be born and his parents never to have met. Now obviously the most intriguing part of the films is their ability to travel through time, but actually astronauts have already been able to travel through time to a much smaller extent. Whenever astronauts travel through space near the speed of light, time actually moves slower for them on the spaceship than it does for the rest of the world. Therefore, astronauts actually travel a fraction of a second into the past when they're traveling at this speed. For example, astronaut Scott Kelly just recently returned from a 340-day journey around 8.6 milliseconds younger than when he left. But still, scientists have been asking the question for years: is real time travel actually possible according to the laws of physics? Well, Stephen Hawking, the widely acclaimed physicist and cosmologist, didn't think so. In 1992, he proposed the chronology protection conjecture, which said that time travel should be impossible according to the laws of physics. However, more recently, Hawking changed his mind, saying that time travel may be possible, but is not practical. But nonetheless, there are still several methods that scientists have proposed for time machines. Many of these involve super fast spinning or quantum effects, but the most likely and most promising solution is something called the traversable wormhole. A traversable wormhole uses a hole in the space-time continuum through which people can freely travel back and forth in time. In order to create this wormhole and keep it open though, we would likely need what physicists call exotic matter. Exotic matter is matter that is actually repelled by gravity instead of attracted to it, and it also has less energy than a vacuum, which is what scientists call negative energy. Exotic matter and negative energy have been proven to exist in small quantities, so the real challenge with creating the traversable wormhole is getting a large enough amount of exotic matter in one place to create the traversable wormhole. In a time machine that takes advantage of traversable wormholes, we would have two chambers, each consisting of two concentric spheres separated by a tiny distance. After imploding the outer sphere, the two spheres would have negative energy due to something called the Casimir effect. Then we would have to string a wormhole between the two chambers. To allow the wormhole to transport objects through time instead of just space, we would need to send one of the chambers through space at near light speeds, which would cause time to slow down on that chamber. Now, if you're in the second chamber, you can travel through the traversable wormhole into the first chamber and actually travel back in time. Although this method sounds very cool and exciting, there are still several problems that would prevent us from actually building it. First, the wormhole may be very tiny, even smaller than an atom, so we wouldn't really be able to fit through the wormhole. Also, as I mentioned before, it's very difficult to create enough negative energy to keep the wormhole open for long enough. Another drawback is that you would only be able to go back in time to when the time machine was actually created, because before that, time would be beating at the same rate in both chambers. However, this would explain why there are no time tourists coming into us from the future all the time. Finally, it's possible that traveling through the wormhole can create a massive buildup of energy that destroys the machine before it can be used. Now, time machines aside, you may be thinking that time travel should be impossible due to the paradoxes it creates, like the grandfather paradox, which says that if you go back in time and kill your grandfather, how can you still be alive? Well, scientists have been thinking about this for years, and there are several ideas for ways these paradoxes could be solved. For example, it's possible that traveling into the past only lets you repeat past history, and you wouldn't have any free will to change the past and cause such paradoxes. It's also possible that you would have free will, but only within limits. So if you attempted to create a time paradox, some force would stop you from doing so. The solution that Doc explains in Back to the Future is that when you go back in time, the timeline actually splits into two timelines or two alternate universes. So everything you do when you're in the past is actually happening to technically different people because you're in a different universe. Therefore, it's possible to go into the past and create an entirely different universe that would continue as you enter the future. In Back to the Future, we see this when Biff steals the almanac and makes himself rich and famous in the future, therefore creating an entire alternate universe that Marty is completely unfamiliar with. Another interesting technology that may be more feasible than time travel is the hoverboards that Marty sees when he travels to the future to the year 2015. Engineers have already managed to build maglev trains, which are trains that hover slightly above the ground over magnetic tracks. Actual hoverboards using the same maglev technology have also started to be built. Superconductors are materials that have zero electrical resistance below a certain temperature, and they are also able to resist magnetic fields. Therefore, if a magnet is brought near a superconductor, the magnet will be repelled, causing it to levitate. Lexus recently created a hoverboard using this technology, with liquid nitrogen-cooled superconductors and magnetic tracks. There are a few drawbacks, including the fact that the battery only lasts around 15 to 20 minutes, and it takes an hour or two to charge, and the fact that you always need a magnetic track under you, but Lexus already converted a skate park in Barcelona into a hoverboard skate park by laying down hundreds of tiny magnets into the cement and wood, and this actually worked really well for the Lexus hoverboards. With time, this technology will become cheaper and more efficient, so maybe soon skateboards will be a thing of the past. So in conclusion, time travel is impractical as of now, but it's not theoretically impossible with a solution like a traversable wormhole. And levitation through hoverboards has actually already been achieved with superconductors, but it may still take some time to improve this technology to make it just as great as it was in Back to the Future.